Welcome to lecture number 10, and we have started discussing about inductor, its terminal relations between voltage and current. And I told you that if there is an inductor, ideal inductor having no resistance, if you show the voltage applied across it to be V t, this means potential of this point with respect to this is V t, and if you show this current to be I, which is expected to be a function of time also, and then the relationship between voltage and current will be L d I d t. You should be consistent in noting the polarities of the voltage as well as the direction of the current. Now, from this we showed that the current I will be nothing but 1 over L and integral V dt, V dt. Now, what should be the limits of the integration? That is, the current at the present time t depends upon all the voltages, that is t equal to minus infinity to t. Okay. Sometimes this creates confusion, t equal to here also dt. So, this integration, this definite integral will not change if you give it some other variable v tau and d tau, and write t equal to minus infinity to t. That is this is one and the same thing, because it is after all a definite integral. So, the change of this variable you can do anything. So, I have written it to be tau inside, and I am interested to know the current at time t. So, this will be the thing. Therefore, we note that this inductor present current, to integrate this you will require the value of v tau, that is V t, for all the time. If this is your time axis, here is your t equal to 0, this we discussed, but I am just telling that all the informations, and this is suppose your t and this is your tau axis. So, you require all the values of the voltages till time t. This V tau dt, this is V tau, this voltage, if you integrate from this, it means this area under this curve, that is what I told last time, and this you have to take till t equal to time t. So, this is t equal to infinity, minus infinity. Therefore, inductor, unlike resistance, the current, present value of the current in the resistor is dependent solely on the present value of the voltage. No previous voltages are required, but in case of inductor, present value of the current depends upon the past history of the voltage that we applied across it. So, this is the thing. So, therefore, inductor is said to be a device or an element with memory. It remembers how you treated the inductor previously with what kind of voltage, that it makes sense. Anyway, so this is the thing. So, inductor is a device with memory. Now, this input voltage across the inductor, this V t is the applied voltage, current is the consequence current, and these are the relationship in differential form, and this is the relationship in integral form. Now, naturally, the question is not it to find out the current at time t, you require all the previous voltages, things like that. We will assume that this input voltage V t is a reasonable signal is a reasonable signal, reasonable signal. Reasonable signal means it is not an impulse function or any function. It may be exponential, it may be triangular wave, it may be a step waveform, it may be sinusoidal, what not. Those are all reasonable signals. Input voltage is a reasonable signal, that is V t, I will exclude V t for the time being. V t excludes an impulse signal. Your input signal could be also an impulse signal, which is generally denoted by delta t. Except for that, we are discussing now at present. We will see the implication of this impulse excitation of a circuit later in great detail, that we will do that. But for the time being, we will assume V t is not an impulse, it excludes impulse. Now, if that be the case, then your I t is like this. Okay. Acha. Now, suppose an inductor, across an inductor at t equal to 0, let us try to understand t equal to 0 business. This is t equal to 0. Now, at t equal to 0, I am going to apply some voltage across the inductor at t equal to 0, and that voltage is known to me, whatever voltage I will apply. Now, as I told you, and I will be interested to know the current at time any time t, that is what my goal is. But as I told you, the current at time t will depend upon all the voltages integrated up to time t, including the known voltage here, and for t less than 0, I am not sure what voltage I applied, things like that. Unless it is known, it cannot be done, but I will tell you how this problem can be tackled. See, for example, the value of the current, suppose I take, I am showing in a larger scale, suppose you take a time here, this vertical line is t equal to, this point is crucial. Okay. This is t equal to 0, t equal to 0. Now, you take 2 times here, one left to t equal to 0, which is lesser than t equal to 0 by a very small amount, maybe 10 to the power minus 32, whatever way you think. So, that time I will tell is at t equal to 0 minus, that is very close to 0, but left to t equal to 0. This point is t equal to 0. Similarly, on the right hand side, immediately after t equal to 0, I will denote the time by this notation, t equal to 0 plus, means it is almost 0, but on the right hand side. Now, why it is necessary? And this I have shown in a larger scale. It is like this, what I am trying to tell, this is t equal to 0 and t minus 0 is here, t 0 plus is just here immediately after that. So, 0 minus and 0 plus indicates those 2 points. Acha. Now, you see, suppose I want to find out current through the inductor at t equal to 0 plus, this I want to find out. What should I do? I should then write this should be equal to 1 by L t equal to minus infinity, this upper limit becomes 0 plus, t equal to 0 plus, is not. and V dt. This is what I have to do to find out the current at t equal to 0 plus. At t equal to 0, something happens to the circuit. I have applied a voltage, some change has occurred. So, this must be true. Now, this integration can be, this step is very crucial, I 0 plus will be equal to 1 by L. This integration I will break it up into two parts, t equal to minus infinity to t equal to 0 minus b dt, bt dt, I am sorry, there is dt here, you are doing integration, this one plus 1 by L integration t equal to 0 minus to t equal to 0 plus v dt, vt dt, is not. So, the same thing is now broken up into two pieces. One is from minus infinity to 0 minus you integrate, then from 0 minus to 0 plus to get the current at I 0 plus. Okay. Now, as I told you, our voltage signal is a reasonable signal, not an impulse. What impulse is, we will discuss later. Therefore, what will be the result of this integration? Let us ask ourselves, what will be the result of this integration? The result of this integration has to be 0. Why? Because of the fact, suppose B t is like this. Then I am trying to integrate, this is suppose B t. In the interval 0 minus to 0 plus, and these are as small as possible in the calculus sense. Therefore, area under the curve will be practically 0, because you have gone a little here, a little this side. So, area enclosed by this is nothing but the area enclosed between 0 plus to 0 minus. That area will approach 0 because of the fact 0 plus is only you have crossed 0 immediately after that. If you say I have crossed by an amount 10 to the power minus 32, I will say no, it is 10 to the power minus 64. That is the sense of, but nonetheless it is some positive number by which you have crossed 0. Similarly, this is as small as possible, these interval are as small as possible, as small as possible as you think, but it has this distinction, it is not t equal to 0, that is what I am trying to tell. Similarly, this fellow, this is also as small as possible, this fellow, this interval. So, 0 plus is a number which is practically 0 for all practical purposes, but it is to the right of t equal to 0. Therefore, these 2 points collapses. Therefore, you will get a very thin sheet. Therefore, area under this curve has to be 0 for all practical purposes. If that be the case, then so this is the thing. So, if that be the case, then let us see what is I 0 plus. I 0 plus will be then equal to this whole integral is equal to 0, this part, it will be 1 by L t equal to minus infinity to 0 minus b t dt, because and then plus 0, this term is 0. But what is this thing by definition? 1 by L t equal to minus infinity to 0 minus, it is nothing but I 0 minus, because I have written I 0 plus like this. This is the general time t, how much will be the current. So, I am rewriting using this relation, from this I get this I 0 minus. Of course, you have understood, but I am still writing what you want to know current at t equal to 0 minus, then integrate the voltage applied across the inductor from t equal to minus infinity to t, that is 0 minus. So, this integral is nothing but the current at 0 minus. Therefore, this is the crucial thing. We note that I 0 plus has to be equal to I 0 minus. Got the point? Therefore, from this we conclude that an inductor excited by signals which is not an impulse signal, the current existing just prior to your switching in the circuit, that is I 0 minus whatever it was, and you are doing something here, then at t equal to 0 plus, immediately at t equal to 0 plus, it is equal to, these two currents must be same, that is current through an inductor will be continuous, it cannot have a sudden jump. Is that point clear? That is one point. And second point is, see your that previous history, this one I will write it in a special way, that I 0 minus what we have seen, it is equal to 1 by L t equal to minus infinity to 0 minus V t dt. This is the thing. Therefore, to solve the circuit from t equal to 0 onwards, as I told you, one may demand that okay, I must then know what are the voltages you have applied before t equal to 0 minus, that is one thing. But see, this previous history, all this previous history is nothing but to say that inductor, when you are doing some switching, had an initial current I 0 minus. It captures the previous history. This current in the inductor at t equal to 0 minus is this whole thing. Therefore, our anxiety that I must know that is the one thing, if all the voltages are given, I will be able to solve it, that is okay, you have to integrate. But another way of telling this is this current I 0 minus captures the previous history of the inductor, that is how you treated the inductor will be written in this I 0 minus itself. In other words, what I will then write, that current through the inductor at any time t will be, and t greater than 0, suppose at t equal to 0 I am doing something, it will be equal to this way, then I will write 1 minus L t equal to minus infinity to, let me write that one also, t V t dt. This is what I have to do. This I will now break up into 3 zones, 3 pieces, 1 by L t equal to minus infinity to 0 minus V t dt plus 1 by L integration t equal to minus infinity to 0 plus, sorry, t equal to 0 minus I have reached. So, 0 minus to 0 plus V t dt, this I will do, and then plus 1 by L t equal to 0 plus 2 t. This is what it looks like. Then I will say current at time t I t will be, this part is nothing but current at I 0 minus, and this part, as I told you, if V t is not an impulse, this will be equal to 0 plus this third part, only you have to integrate, where you know the what kind of voltage you are applying. You play with that, t equal to 0 plus 2 t. So, this is the story how inductor current at any time t can be found out, if you have done some switching at t equal to 0. Now, for us, those who are using this circuit, for them t equal to 0 minus or 0 or 0 plus, this is as good as 0, is not? What is the difference? We cannot make any difference, but your inductor will make the difference. So, that is why people say that this is the thing, and what is I 0 minus? So, I 0 minus this one, and with this condition that I 0 plus will be equal to I 0 minus. This has to be, inductor current has to be continuous. I think you have got the point. We will solve some small problems to emphasize this point further. But this is absolutely essential that you must be very clear about what you are doing. Okay? Now, this inductor, so sometimes suppose I say that an inductor, now inductor is an energy storing element. Inductor, this is very important, inductor can store energy, Now, suppose you have an inductor, pure inductor L, okay? And here for t less than 0, no voltage was applied. Try to understand all the points I am telling. For t less than 0, the voltage applied across the inductor was 0, suppose. No voltage was applied. And at t equal to 0, we apply a voltage V t, and V t could be any reasonable function, that is all. So, game starts here from t equal to 0. Now, the question is, I must say that inductor current was 0, t equal to 0 minus was 0, because you did not apply any voltage. If the inductor was kept open circuited, anyway that current must be 0 before t less than 0, and I say that okay, I 0 minus is 0. So, that is there. Now, I will impress a voltage V t appears for t less than equal to 0. I have applied a voltage across the inductor which is like this, and I want to solve for the current. So, I will say current through the inductor at any time t for t greater than equal to 0 will be equal to I 0 minus plus 0 minus to 0 plus that integration will be 0, then 0 plus b t dt by 1 by L. This will be the applied voltage across the inductor. And since I 0 minus is 0 okay, at any time t, since I 0 plus I 0 minus is 0. So, this I will write it as this one. And which is for all practical purposes. So, far our time thing is concerned, it is equal to 0 to t v t dt. This will be the case. For example, somebody says that V t for t greater than 0 is a battery, constant voltage. This V t is a battery, V with this polarity you have applied. This is your IT, mind you. So, suppose if you applied a constant voltage V, then you will say the current through the inductor which had no initial current, this is called initial current. So, here is the practical example. Previously you did something and whether you did not something, I 0 minus was 0, it is given to me. Therefore, current at any time t is I 0 minus plus 1 by L etcetera, and then I say that this V t is constant. Then what will happen? 1 by L 0 to t V into dt I will write. So, this will be equal to V by L into t. So, current through the inductor, if you apply a constant voltage, will be equal to V by L into t. This will be the solution. And it is always better you sketch the current. So, the current sketching will be for t less than 0, you did not apply any voltage, V t was 0, therefore, current was 0. This is t equal to 0, this is t equal to 0. So, what was the current at t equal to 0 minus? It was 0. What will be the current at t equal to 0 plus? Once again 0. It cannot start abruptly from some other value, okay? Which means this I 0 minus 0 means I will immediately conclude I 0 plus is 0. So, it has to start here. For me, it does not make any difference 0 minus 0 and 0, this is t equal to 0. Okay. And then I notice this being constant y equal to m x. So, the current will increase linearly. This is time and this is the current through the inductor. It will go on increasing linearly. So, apply a constant voltage across a pure inductor, current will rise linearly. The slope of this curve depends upon the magnitude of the voltage, constant voltage by L. This is constant, battery you have connected. To give a simple example, of course, you can easily see I should not apply a constant voltage across an inductor for long. If you do, what happens? As time passes, current limitlessly go on increasing After all, you have made the inductor with a wire which has got a definite cross section, it has got a definite current carrying capacity. Therefore, if you just keep a battery connected across a pure inductor, after some time you will see smoke will come out from this coil, because your coil cannot bear this current, there will be fire. Each wire with which you have made the inductor has got a current carrying capacity. Suppose 5 ampere is the current carrying capacity of this inductor. Therefore, I will say in that case, suppose I rated of this coil is equal to 5 ampere, suppose. And here is this 5 ampere mark. Then I will say, okay, if you apply a constant battery voltage across an inductor, and this is the time axis, you can apply safely that voltage up to a definite time, 5 ampere, you know V by L, you will be able to calculate what is the value of t. Up to this capital 0 to t, if you connect the constant voltage, current will rise from 0, it will reach 5 ampere, then take protective action. No, I should not allow this voltage to act upon the inductor further, because it will then go beyond its rated current and your inductor will be spoiled. It is dangerous. So, constant voltage can be applied across an inductor, but for how long, that you decide, depending upon the current rating of the inductor. Anyway, we will address this problem. Now, as I told you, I will concentrate upon energy storage in an inductor. Unlike resistor, whatever is the power, I square R or voltage across resistor into current, they are one and the same thing. That power is a resistor will always receive power, and that power, whatever it receives, it immediately dissipates into the atmosphere. The power that you have injected in a resistor will be lost and lost forever. You cannot recover that power back. We will see in my next lecture how inductor can store energy. Okay? Thank you.